Limit. A function f of x is said to tend to a limit L when x tends to a if the difference between the fx and L can be made as small as we please by making x sufficient near a, and we can write this expression as limit x arrow towards the a f of x equal to L. दिस एरो इंडिकेट्स दैट एक्स इज टेंडिंग टूवर्ड्स द, मतलब कि एक्स की वैल्यू है जो है वो ए की तरफ बढ़ रही है, एंड लिमिट हमेशा किसी ना किसी फंक्शन की ही निकलती है. एंड लिमिट्स दो टाइप की होती हैं, राइट हैंड लिमिट होता है और एक लेफ्ट हैंड लिमिट होता है. राइट हैंड लिमिट, द फंक्शन एफ ऑफ एक्स इज सेड टू पोजेसेस अ राइट हैंड लिमिट एज एक्स अप्रोचेस ए फ्रॉम द वैल्यूज ग्रेटर दैन ए. मतलब कि एक्स की वैल्यू जो है ए की तरफ अप्रोच होती है, एक्स की वैल्यू जो है ए की तरफ अप्रोच होकर ग्रेटर होती है, ग्रेटर दैन ए होती है, तो वो राइट हैंड लिमिट होता है. लिमिट एक्स टेंड्स टू ए प्लस, इट मीन्स दैट इट इज वैल्यू इज इंक्रीजिंग ग्रेटर दैन द ए. The plus indicates that the value is greater than the a. So limit x tends to a plus f of x, or limit x tends to a plus 0 f of x, and hence it is right hand limit. Left hand limit, the function f of x is said to possess a left hand limit as x approaches a from the values less than a. मतलब कि x की वैल्यू जो है वो a की जो x की वैल्यू जो है वो a की तरफ अप्रोच करती है और उसकी वैल्यू होती है वो लेस होती है. लिमिट x टेंड्स टू a माइनस f of x, और लिमिट x टेंड्स टू a माइनस 0 इज इक्वल टू f of x. दिस एक्सप्रेशन इज called as left hand limit. Now is the question, limit x tends to 1 x square minus 1 upon x plus 1. Limit, we can write this x minus 1 and x plus 1 upon x minus 1. Limit x tends to 1, x minus 1 got cancel out, x plus 1. Putting the values in the x, which is 1 plus 1 is equal to the answer is of this question is 2. Now, in the second question, we can see that limit is extending towards the infinity. Now, the limit is extending towards the infinity. By expanding this brackets, we can write this limit x tends to infinity 2x square plus 5x plus 3 upon 3x square plus 10x plus 8. In this type of question, we can put x equal to 1 upon y as x is tending towards the infinity and y is tending towards the 0. Limit x tends to infinity 2x square plus 5x plus 3 upon 3x square plus 10x plus 8. Limit, now y tending towards the 0, 2 by y square plus 5 by y plus 3 upon 3 by y square plus 10 upon y plus 8. Limit x tends to 0, 2 plus 5y plus 3y square upon 3 plus 10y plus 8y square. Putting the values of the y, we get 2 plus 0 plus 0 upon 3 plus 0 plus 0. Therefore, the answer will be 2 by 3. Now, there are also some trigonometric limits. Trigonometric limits में limit x tending towards 0, sin x by x equal to 1, limit x tends to 0, tan x by x equal to 1, limit x tending to infinity, sin x by x equal to 0, and limit x tending to infinity, cos x by x equal to 0. Now, there is a question, limit x tends to 0, x cube upon sin x square. Limit x tends to 0, we can write x cube as x square upon sin x square dot a multiply into x. Limit x tends to 0, x square by sin x square into limit x tends to 0 x. Limit x square by sin x square value will be 1 and its value will be 0. Therefore, the whole answer will be 0. Now, this is the trigonometric limit. Now, continuity. रियल फंक्शन को तभी कंसिडर करेंगे किसी भी पॉइंट में जब उस फंक्शन का ग्राफ प्लॉट करेंगे और उस ग्राफ में कोई भी ब्रेक नहीं होगा किसी भी पॉइंट पर. दैट इज अ रियल फंक्शन शुड बी कंसिडर्ड एट अ पॉइंट if and only if the graph of the function has no break at a point under the consideration. Now, a function f is said to be left continuous. Function को तभी left continuous कहेंगे at x equal to c if and only if the f function of c exists. The limit of x is tending to c minus the f of x exists, then only limit x tends to c minus f of x will be equal to f of c and the function is said to be the left continuous. Next, a function f is said to be right continuous at x equal to c if and only if the function of c exists, the limit x tends to c plus the f of x exists, and limit x tends to c plus f of x is equal to f of c, and hence the function is said to be right continuous. A function is said to be continuous at point x equal to c if and only if the function of c exists, limit x tends to c, f of x exists, and limit x tends to c will be f of x equal to f of c, and hence the function is said to be the continuous function. Now there is a question that show that the function f of x equal to 2x mod x minus mod x is continuous at x equal to 0. The function of f(x) is equal to 2x minus mod x, which means that it has 2x minus x, that is if x and 2x minus x if x is less than 0. F of x will be x and 3x. X when x is greater than equal to 0 and 3x when if x is less than 0. Now here the function will be 0, limit x tends to 0 minus f of x is equal to limit x tends to 0 3x which will be 0, and limit x tends to fx will be equal to limit x tends to 0 plus x would be 0, and then the last one, limit x tends to this f of x equal to limit x tends to 0 f of x which is equal to f of 0. Limit x tends to 0, f of x is equal to f of 0. Therefore, we can say that function f is continuous at x equal to 0. Hence, we have proved that the function is continuous at x equal to 0 because all the three conditions, that is the left continuous limit, the right continuous limit, and the continuous at x equal to 0 exist, and hence the function is continuous at x equal to 0. Differentiability. A function f is said to be differentiable at a point c if and only if the derivative of the f at c exists. मतलब कि जब अगर derivative f का exist करेगा then only the function f is said to be differentiable. The process of finding the derivative of a function is called the differentiation. Now, derivative at a point. A function f is said to have a derivative at a point x if and only if it is defined as some neighborhood of the point x and limit h tends to 0, f x plus h minus f by x by h exists. This is the derivative at a point. Find the left hand and right hand derivatives of f of x minus 3 where x is less than 2x minus 5 where x is greater than equal to 2 at point x equal to 0. Hence show that the f is not derivable at x equal to 0. We have given that, we write first of all given f of x equal to x minus 3 2x minus 5 x is less than 2x and greater than equal to 2. Now since f is defined in a neighborhood of 2, and f of 2 will be 2 dot 2 minus 5, which is equal to minus 1. F plus 2 is equal to limit h tends to 0 f 2 plus h minus f of 2 upon h, limit h tends to 0 2 2 plus h minus 5 minus minus 1 upon h, limit h tends to 0 2h upon h, which will be equal to 2. Now f2 is equal to limit h tends to 0 f2 plus h minus f2 by h, limit h tends to 0 minus 2 plus h minus 3 minus minus 1 upon h will be equal to h upon h will be equal to 1. Therefore, hence f2, the right hand limit, is not equal to the left hand limit, and therefore the f is not derivable at x equal to 0. This is because in this, when we have to find the right hand derivative, here the value of right hand derivative is coming 2, and here the value of left hand derivative is coming 1, which shows the right hand derivative is not equal to the left hand derivative, and hence that f is not derivable at x equal to 0. It shows that x is not derivable at x equal to 0. X is not derivable at x equal to 0. So by this, the limit, continuity and differentiability, I may conclude my video.